Machine learning, artificial intelligence. These aren't just buzzwords. They're the future, reshaping our world one algorithm at a time. You see the incredible results. From recommendation engines that know you better than you know yourself, to medical diagnoses that save lives. You're inspired. You want to be a part of it. You decide to learn machine learning. But then you hit a wall. You soon realize that the path to mastering ML is far from easy. It's a journey filled with complex challenges that can feel overwhelming. Today, we're pulling back the curtain to talk about why machine learning is so hard to learn, and why pushing through is worth the struggle. The first hurdle for many is the sheer mountain of mathematics. Machine learning isn't magic, it's math. To truly understand how algorithms work, you need a solid foundation in three key areas: linear algebra, calculus, and probability theory. Linear algebra is the language of data. Calculus is essential for optimization, the process of finding the best model by minimizing error. And probability theory allows you to make sense of uncertainty and build models that can make predictions. Without this mathematical intuition, you're just blindly using libraries without understanding what's happening under the hood. Then comes the coding. You might be a decent programmer, but ML demands mastery of complex libraries like TensorFlow or PyTorch. You'll spend countless hours debugging, figuring out why your model's dimensions don't align, or why it's running 10 times slower than it should. It's a constant battle with dependencies, environments, and the subtle art of writing efficient code that can handle massive amounts of data. But even with strong math and coding skills, you face what many professionals call the biggest challenge of all: data. Machine learning models are hungry for data. But in the real world, it's almost never perfect. It's messy, incomplete, and full of noise. A huge chunk of a practitioner's time, sometimes up to 80%, is spent on data wrangling, cleaning, pre-processing, and handling missing values. As the saying goes, garbage in, garbage out. Without high-quality data, even the most advanced algorithm is useless. There's also a significant gap between theory and practice. You can read every textbook, but applying that knowledge to a real-world problem is a completely different ballgame. This is where you encounter another major challenge: overfitting. This is when your model learns the training data too well and fails to generalize to new, unseen data. It's like a student who memorizes the answers to a test but can't solve a new problem. Learning to diagnose and prevent overfitting is a crucial, non-trivial skill. So, is learning machine learning hard? Absolutely. It requires the mind of a mathematician and the skills of a software engineer. You will face frustration and moments where you want to give up. But here's the secret: every single person in this field has felt that way. The difficulty is the barrier to entry, and overcoming it is what makes the skill so valuable. It's a journey of continuous learning. So, embrace the challenge, because on the other side of that steep learning curve lies the power to build the future. The struggle is part of the story,